Welcome back, part 2 of the Wolseley WD1 restoration. This is a video of short videos on some of the bits I've had to make to get us back to where we needed to be so we can put it back together. Some of them I found out the hard way, as you'll see. I didn't video everything, but we're at a point now where we need to get the block painted, deal with that horrible frost repair on the side that we can just improve a bit, and then get the thing built back up. So that will be part 3, and we'll get it running in part 3. If I'd have filmed everything that I've made, this video would be an hour longer than it already is, and it'll all be asleep by the end. So hopefully you'll enjoy the snippets I've put together. Now I need to make a drive, this thing, which is a mag drive for this Wolseley WD1, because the stupid camera will focus on it. This has got a crack in it there, and this bit here is loose. It's going to fall to bits. Now I cannot get one of these for love nor money in the UK, and also the dimensions I'm coming up with are different to this one. It's odd. There's a lot of things about this WD1 that are build. Also, I don't know whether the camera will pick this up. We'll have a go. I'll get the light on it. These two drive pegs, which this sits on, are different dimensions. This only goes one way, which again is a bit odd, and it's also like it's been machined. Somebody's had a go at it. I don't know, it's very difficult to tell, but normally you can put these, in my experience of WD1s and 2s and the Russell ones with pt2, you can put these in, put it on, mag goes on, away you go. So I haven't got any fibre. This is made of a fibre resin sort of material. I haven't got anything like that, but I have a lump of brass kicking around, which is plenty big enough in the come in handy brass sort of box. So I'm going to put this in a lathe, and the hole in the middle is just a clearance hole. The OD doesn't matter. It's the two slots that matter. They need to be 90 degrees apart. Obviously doing the first one is fairly straightforward on a rotary table in the mill, or even on a vise. Just centre it up and cut it with a right size cutter, but of course it's then, yes, you can turn a rotary table through 90 degrees, but you've got to flip this as well. Make sure you don't turn it in the chuck. So that's going to be a tricky bit. Well, I'll get this up a bit better. We'll get this in a lathe, I'll drill this out, deburr it and that, and part it off the right thickness. Then we'll get set up on the mill and see if we can make one successfully, because there's no point using the old one. It's done and it'll fail. Now that does look a bit precarious in there. It's only nipped on, but it should be fine, because I've got to get my parting off tool up. Once I've drilled this, I need to part this off, so I've got a ring, and then we can mill. So you know, the joys of using a little tiny piece of material, but waste not, want not. Right. Now, so this is just a clearance hole. So, and I measured up. I'm using the dimensions off my old fibre coupling as it worked on this engine. It's clearly been running like it, and it wasn't bottomed out like it's too deep, because it's a bit thicker than the dimensions I can find on the internet. But it's actually a 26mm hole, clearance hole. So I'm just going to drill the 26mm clearance hole. Where are we? Let's slow that down a bit. Just deburr that. Right, I'll knock that sleeve off in a minute. Now I need to set the parting off tool up. There you go. I just need to deburr it, and we can get set up on the mill. Now I'll set this up. This is the easy one to do, because obviously I've got to work out how to flip this and turn it 90 degrees. I'm doing half mil cuts because this is only just nipped in here, and we don't want it coming off and going across the workshop. I've got to go down 6.5 mil, which is the clearance depth according to the original that I've got, so we'll go with that. All I did was just touch the cutter off on the surface, make sure it was parallel. And then started going backwards and forwards. And you got to remember, we're not making parts for a Formula 1 race engine here. It's a stationary engine, with the other one was plus or minus a gate post. And we've been quite happy to get away with quite a bit on here. Now I know some of you are going to say, well, that's going to be too heavy compared to the old one. Well, yeah, it will be heavier than the original. But I don't see that it's going to be a problem, being it's being driven by a steel gear driving a steel mechanism on the back of the mag. Right, I know 6.4 is plenty of clearance, because the original drive didn't go that deep. Right, let's just get my gear. This is the gear end. Perfect, and that should now fit both ways. Yeah, it does. So now I've got to work out how to get that 90 degrees round and the other way up with a different size cutter on it. Now I couldn't think of any easy way of doing this, or really easy, and I'm only making one. If you were making a batch, you make a fixture where you cut one of the slots and then the fixture flipped it over, located it on the bed, and then cut the other one, so you could do a batch of them. What I basically did was use a centre square, marked up the centre of that slot going that way, use a protractor 90 degrees to mark a line that way, and this is a wiggler, which you spin it up and it runs off centre to start with, and you use a tool just to get it to run centre, nip it up, and then basically I could set this up. This is all locked off now. I can follow my line. You won't see it on the camera because I just can't get in there. I can basically, the pointer on the end of here follows my line exactly. And that's good enough. You got to remember what we're doing here. It's not, as I say, an F1 race engine or anything. It's a stationary engine. This will be more than adequate for this job. I just got to change the tool, a different collet in. Also, I've got a 1/4 inch cutter, but it needs to be slightly bigger. So I've actually, once I've cut the slot, I need to move the table that way 0.1 and this way 0.1, and just tickle it out and make it slightly wider to give us clearance for the mag drive. So let me just swap this over. Right, done the same again, put the 1/4 inch tool in, literally just tickled it, touched off, zero my Z axis, and then we're going to go up. This is a slot drill, by the way, so we're going to go at 1/2 mil at a time and do the same again down to about 6.4, and then I need to just go a little bit each side, so we'll quickly do this. Right, now we're at the right depth. I need to go, doesn't matter which way I go first. So this is zeroed up here, so I'm going to go 0.1 in that, minus 0.1 in that direction. Again, it's clearance. going to go the same the other way. Lock it off. And the compressor's turned off because the lights are extra lights are plugged in. But hopefully, the one this way. Let's have a measure and see what we've got. Yeah, that's fine. Instead of being 6.4, it's 6.5, so we're slightly up. I don't think I can get that in there. All the gubbins in the way to make that fit, but go down and see if we can get that in there. It should now fit. I've got to deburr it yet. Yeah, there you go. Slidey fit, perfect. I'll just deburr it. So there you go. If you wanted to make it lighter, you could drill holes in it. Get rid of some of the weight. I don't really see as that's necessary. So it's been driven by steel gear and driving a steel coupling. So and once the engine is running, it's, you know, I know there's a bit more mass there. I mean, doing the slots the way I did it, working out in the 90 degrees, I say if you were making these in a production line or doing a batch, you make a fixture to do it, speed it up, and you get the right fibre material. But you know, I'm just making one for my own use, so it's not worth it. So right, on to the next bit. Right, next job. I had a look at this fuel tank, cleaned it up a bit, stuck it in shot blaster. I'll bring it over. I don't know if this is going to pick up on the camera, but this is full of holes. You strain your veg through this, it's had it. There is no point trying to repair this. That's why it's full of plastic pudding. So I need to get the fuel filler neck out and the tap fitting boss out. Hopefully it's just soft soldered, not silver soldered, and we can unsweat it, otherwise I might have to get the oxypropane to it. And I also shot blasted the exhaust, and it had one hole in it we knew about, but it's got loads of holes in it. This stupid camera will damn well focus. Right, it's, yeah. Now, these are about, I think 68, 69 quid, call it 70 quid per post for argument's sake. I'm not going to be able to repair that for that. You can't get a replacement tank, no point trying. They just don't exist. If you can find one, it'll be in the same state as this one is, so I need to make a new one. I've got plenty of material. Basically, I measured up, this is 250 mil wide, and it's 140 mil diameter. Well, 140 times pi is 440, so I need a bit of material. I've got some 1.5 mil mild steel, which I can cut and then roll up on my slip rolls, and then TIG weld it, and I will make ends. Now, I'm not going to roll the ends in like these are, and I'm just going to use a flat plate and TIG weld it on, because it's just easier. I'd have to make a dolly to then, you know, a block to dress that round. Sorry, on a dolly, and for one, and I'm not doing it. Anyway, let's get this apart. I'm going to get the gas going and warm it up and see if we can unsolder these pieces, and we can clean them up later. And then we'll get set up and I'll start making a tank. Right, so I'm just using a ordinary propane torch. What do with my lighter? With the biggest nozzle I've got. Hopefully that will be big enough to get it off tonight. It should be if it's soft soldered. Let's give it a go. And obviously be careful messing with fuel tanks. This hasn't had any fuel in for 15 years, so it should be absolutely fine. Oh yeah, that's melting away nicely. Hasn't been sort of pressed in some. Yeah, this tank is so soft, you just touch it and it moves. Oh yeah. Yeah, it's all caved in. Maybe we just knock that off then. Let's see. I'm hoping there's not a nut or something daft on the back. That would be a bit weird, wouldn't it? On a cold day like today, it's quite nice doing a job like this. So we can get all the solder out, so we can get it apart. The only other way is take disc cut to it. There we go. Yeah, there is a nut on the back of it. Would you Adam and Eve it? I thought they were always sweated in. There you go, learn something every day. Does he try not to break his neck falling over that? But there is a nut. I don't know the camera. You see that? There's a nut on the inside of that. I never expected that. Anyway. I just thought they were soldered in. I thought wrong. Let's go and find the right spanner. Right, let's see if we can get this apart. It's probably, yeah, that solder might have solidified again. Let's warm it up again. Yeah, that's what's happening. The solder is solidifying as it cools. Voila. Okay, we've got that bit out. Now let's have a go with the with that bit. I need a stand to hold this on so I can leave it lit. Now the fuel tank is actually, when they make the hole for this, it's pressed outwards, and there's like a locating ring that this sits on. Now I don't know how good a fit that is. What we can do is warm it up and see what we get. It looks Oh, there it fell off. There we go. Yeah. That has it sits on that and then it's sweated on. So those are the bits we wanted off of there. This will clean up and resolder. Not a problem. Excellent. Now we need to make a new tank, so we'll get reset up. I'll sort some material out. Got a bit carried away, didn't stop to really show you what I did, but I rolled up a new tank, and I ended up in the end making, I don't know whether the camera will pick that up, but there's a little top hat I made that goes in here to give that mechanical lip that the old tank had, and then this bit I will solder on there like that. It's a good fit. I've sweated in, or soldered in, grandfather used to call it sweating things in, the original fitting there. So basically I need to weld this end on and put a bit of damp cloth around the bottom to make sure we don't get any heat transfer and melt that solder. Let this go cold and then solder this on, and then that's that tank made. So I will get set up and I will film welding this up and sweating that on the last little bits. Right, hopefully this will come out alright. I stuck a lump of stuff on there to hold it in position. Need to change the glasses, which will immediately steam up because it's cold today. And we'll tack it on, and I'm going to weld it round. I will pressure test this once it's all finished and gone cold in a day or two. Make sure we haven't got any bubbles. Right. Glasses are steaming up. Yep, that's pretty good. I'm going to let this cool off and then we're going to solder that top piece on when it's cooled down. I just want to stop too much heat transfer melting the solder in the bottom. Right, cooled down, and I'll put regular soldering flux under here, and I've got some flux cooled solder here. We're just going to try and get this hot enough to solder it with a gas torch. The bottom one worked alright, so let's just give it a go. Nearly temperature. There we go. Running down that side a little bit. So, and of course this was already soldered once to the original. So, yeah, it would appear to have some solder in here as well. I think we'll call that good, let it cool off and clean it up. Need to leak check the tank. I've got my pressure gauge, vacuum gauge hooked up. I'm not too worried about reading what the gauge says because obviously we've got lots of joints that may fizz and bubble. The easiest way to do this, and you can do this with a hand pump, bicycle pump, foot pump, or compressor, whatever, bucket of water, and it's cold this morning because we had snow last night, and just stick it in the tank and hold it for a minute and just check your seams. And even if there's a minuscule leak, because the gauge is moving slightly, or say any of that could be one of these joints, you would see a tiny little bubble appear. because petrol will find its way out the nearest pinhole. And I've been messing about with this morning. I made a rubber gasket to go inside the fuel cap to block off the vent hole and just hold it and check we haven't got a bubble appearing from anywhere that I've welded was likely to be a joint. And so the gauge has moved such a small amount. It seems to go down a bit quicker when I stick it in the cold water. Maybe because the tank contracts, I don't know, but I can't see any bubbles, even the odd little tiny one. I've had it before where you get a minuscule little bubble appear every now and again, and I cannot see anything. So you paint it, and if there's a leak, the petrol will find its way out. Absolutely guaranteed. Yeah, I'm pretty happy with that. It's just nothing coming up. And I've been doing this for a while off camera just to see. I'm not going to do any more sanding on the tank or anything. It is what it is. I'm going to dry it off so it doesn't go rusty. But I am more than happy that that is a fuel tight tank. And then it's on to the next bit. I did find on the silencer we've got a few more pinholes than expected. I might put a ring inside it and weld it up and see if that would work, just out of curiosity. So on to the next bit. Now here was me thinking that I could just knock out my said crankshaft bearing out of the Wolseley, a wd1 crankcase, and press in the spare one I had. Haha, I was wrong. That is the good spare ones I've had. A 1.5mm, I think it's 1.5mm or thereabouts, smaller in diameter. So they fell in the hole. I'll bring up the camera, hopefully this will show it. It's also, this bit here is bigger and wider. So the replacement, well, it's showing up very well, basically this is slightly bigger than this one. So you can probably see from the lathe it is plastered in leaded bronze and the milling machine. I ended up making, I didn't video it, a replacement bearing and pressing it in the housing to the dimensions of the original one. Obviously it's a better fit on the crankshaft so it doesn't wobble around. But I found, you know, I've got some photographs of the last one I made, which I'll hopefully pick up on the camera. I found a bit of leaded bronze, I think it's the LB4, in my come and handy bucket from when I made a crank bearing for Lister B type, and I've got the pictures on the wall. I'll turn the camera and show you. Worked really, really well. Ran for years and years and years and years until my son sold it. And I think we did that like 22 years ago. So this bit of leaded bronze was kicking around, and it only was just big enough to have enough material to hold it in the lathe, and it was a bit sketchy at times, but it worked, and I just got on with it and didn't do it. So I think hopefully with there, all the gaskets I can make except the head gasket, and I could make one of those if I really wanted to. I need to buy some valve springs, so head gasket and valve springs we've got to buy in. The piston rings were replaced when whoever had that engine apart, so we didn't need to buy piston rings. There's nothing wrong with them, we gapped them, they're fine. Done the crank bearing, done the mag drive, made a fuel tank. I found the correct fuel tap for it that fits without that monstrosity of adapters. So it's really getting to the point, and I also managed to recut the valve seats and reface the valves and grind them in. So it's just one spring was obviously compressed for many years while it was left in the scrap somewhere, and we can get those. So we need to, so minimal parts to be bought in, because I had a bit of leaded bronze kicking around and got paper gasket material to make the rest of the gaskets. So I want to get the crank built back up. I've got to order some 3/8 BSF castellated nuts for the big end because they're mangled. So minimal parts. So we'll get those bits ordered, and I want to get the crankcase built back up. Crank in, piston in, valves in, that so we can mask all the crankshaft doors up enough. I don't like to just paint it as a blob like it would have been done in manufacture. The engines originally, I believe, were manufactured, tested, and once they passed test and inspection, then they went down the line to be painted and transferred up. So you ended up with a green, grey or whatever colour blob. I like to leave it so I can get doors off and heads off without damaging paintwork if you have to go in there again at any point in the future, because they've been sat for a while, a valve stuck or something. It just makes it makes it easy. But I'll turn the camera around and I'll show you these pictures. I forgot all about it. I was wondering where that bit of leaded bronze came from, and it suddenly dawned on me. It was the offcut from that job. Hang on, I'll turn the camera around. Hopefully this is going to come out all right. I'll turn one of the lights off to get rid of the glare. Well, I did this on my Colchester Student, which is smaller than the Triumph I've got. I used to have a Mascot. I like my Colchesters. But that's a bit of leaded bronze I bought to make the Lister B crankshaft bearing, because my son bought one. He would have been well, I bought it, he wanted it, I bought it, you know how it works. He would have been about 10 or 11 at the time, and he's 32 this year. So, but it was absolutely clapped out. Crank bearing was gone on one side, camshaft was worn, it didn't lift the valves and all kinds of things. And you couldn't get crank bearings at that time. So I made a new one, and I'll just go through. So that was me starting to machine the leaded bronze I bought. And be boring it out. Leaded bronze is not cheap. A bit more boring getting it to the finished size. And then what I did, I got the original white metal bearing. I remember now, I bored it out to press the sleeve in, because a bit of leaded bronze to do the whole thing was so expensive. The right length, because you need more than enough so you can grip it in your machines. I went down this route and it worked perfectly, because these bearings that are top hat shaped, so you've got a wide flange at one end, so you need the OD to be big enough for that, and the ID to be small enough to machine out the correct size. But it worked a treat, and there you go. That was the finished, all pressed in the housing, and I say that ran for years. It shows in events, it ran a big generator until my son sold it. Well, I decided to repair the old silencer in the end. I had a little bit of an offcut from doing the tank, which was exactly the right width to go in the bottom half, so I just shortened it, rolled it up, welded it, and it was a good snug fit. So I actually pushed the dent out that was in here, and then welded through the holes, and it worked out all right actually. And I sprayed it with some heat-proof paint, and it didn't come up too bad, I don't think. It's perfectly serviceable for now. I know it'll need replacing at some point, but right now that's a few quid saved. So we'll call that it for this video, and in part 3 we'll get the whole engine built back up and get it running, which is the whole of the exercise. So I'll say thanks for watching, and we'll see you in the next one.